Okay, number 24 is crazy. And I'm going to do some stuff that might completely seem like witchcraft to you when I do this. And that's okay, because if I was in your shoes watching this, I would think it's witchcraft too. But I'm going to do it the most efficient way for me. And you can do it with the way what's most efficient way for you. And we'll all come out of the same place. So here's what's going on. I'm going to call this the 8 ball. It comes rolling in and it hits the cue ball. That's typically not what happens, but that's just the way I'm going to call it. And it says the 8 ball careens off at 60 degrees from its original direction. And the cue ball ends up going 30 degrees from its original direction. Now it wants to know what is the velocity of the 8 ball and what is the velocity of the cue ball after the collision. Now I'm going to have to break this down. Well, okay, in order for me to do this, I'm going to have to find this piece and this piece. So I'll call this the velocity of the 8 ball in the y, and I'll call this the velocity of the 8 ball in the x. And then I got to find this piece and this piece. We'll call this the velocity of the cue ball in the x and the velocity of the cue ball in the y. Now, the momentum before equals the momentum after. And I'll break this up into the x components and the y components. So, what I'm going to do is I'm going to basically disregard the masses. Because the mass of this is equal to the mass of that and all the masses are the same, I'm just going to deal strictly with velocities. So instead of taking mass and velocity, mass, velocity, mass, velocity, mass, velocity every single time, I'm just going to cut out the masses because they're all identical, and I'm only going to use velocities. So in the x direction, I've got a velocity of 4 and a velocity of 0. And then this, I've got this one, velocity of 8 in the x, and a velocity of the cue ball in the x direction. If you haven't noticed, I got 4 unknowns. I'm going to have to come up with 4 equations, and this is going to get crazy. Now, in the y direction, beforehand, nothing is moving. So there's nothing going up or nothing going down. So this is going to equal that. What I'm going to do is something a little bit unorthodox. I'm just going to rename these. I'm going to give them a different variable. I'm just going to call it y. Because they're both going to be the same. So here's one equation. My other equation is y equals y. So I know that this is y, that's y. So now I only have 3 variables. I need to know this, this, this. 1, 2, 3. So now I got to come up with 3 equations because I have 3 unknowns. I don't know y, I don't know the velocity of cue ball in the x, I don't know the velocity of the 8 ball in the x. So here's one of my equations. My next equation, what I'm going to do is I'm going to utilize the 60 and the 30. I'm going to say the tangent of 60 degrees, the tangent is the opposite over the adjacent. The tangent is y divided by the velocity of 8 in the x. And you might be asking, why am I doing that? I'm doing this so I can create a second equation. So I'll bring this over. So the tangent of 60 is just 1.73. So 1.73 velocity of 8 in the x equals y. So here's one equation. Here's 2 equations. Now I'll make a third equation. So I'll do the tangent of 30 degrees. So I'll say the tangent of 30 is the opposite over the adjacent. So the tangent of 30 is the opposite y over the adjacent velocity of the cue ball in the x. So the tangent of 30 is just 0.577. So I move that over and I get 0.577 velocity of the cue in the x equals y. There's my third equation. So check this out. I got 3 equations with 3 unknowns. you can do substitution, and you can put this crap together. You can put that equals that, and it's just going to get really, really hairy. What I'm going to do, here comes the witchcraft. I'm going to use a matrix. Entering the matrix. Matrices are the most efficient way to solve for more than 2 unknowns, because you guys have only been doing with 2 unknowns for your dinky physics careers, and that's cool. But in real life, sometimes we have lots of unknowns. So here's what I'm going to do. I'm going to call the velocity of the 8 in the x, velocity of the cue ball in the x. I know y in my answer. So I'm going to put equation 1, equation 2, and equation 3 in here. So this first equation, 1, 1, 1 velocity of the 8, 1, 0, 4. This is matrix speak for my first equation. One of these, no y's, and a 4. 1, 1, 0, 4. And then over here, my second equation. I've got 1.73 of these guys, none of these. I have negative 1 y's, and my answer is 0. Same with this one. I've got no 8 in the x's. I've got 0.577 of these. My y's are negative 1 because I'll move that over, and my answer is 0. So I just rearranged these so they're all similar. Now what I'm going to do, I'm going to plug them into my calculator. As a matrix. So in order to do that, you have to use brackets and stuff. So I'm going to hit the bracket, which is the times multiplication. So I'll go bracket, bracket, and then 1, 1, 0, 4. So 1, comma, 1, comma, 0, comma, 4. Close the bracket, open a new one for the next line. 1.73, comma, 0, comma, negative 1, comma, 0. Close my bracket, open my bracket. 0, comma, 0.577, comma, negative 1, comma, 0. Close, close. So there's my matrix is in there. And you can double check to make sure it's all good. Now, to really truly utilize the power of your calculator, you're going to reduce row echelon, RREF. It's just a little function, and it's going to tell me what the answer to this is. It's really sweet. So you go down to your catalog. So hit second function 0, and hit the R button, which is the multiplication, and you arrow down to RREF. Right there. RREF. Enter. And do it of my answer. Boom. And there it is. So this is telling me 1, 0, 0, 1. 0, 1, 0, 3. 0, 0, 1, 1.73. So here's what this is telling me. This is telling me that the velocity of the 8 ball in the x is 1. The velocity of the cue ball in the x is 3. The velocity, well, actually y is going to be equal to 1.73. So I take those numbers back up to the top and I plug them in. Y was 1.73. The velocity of the cue in the x was 3. And the velocity of the 8 in the x is 1. So now what I'm going to do is Pythagorean theorem. A squared plus b squared equals c squared. So 1 squared plus 1.73 squared equals c squared. And it comes out to 2. And then I'll do a squared plus b squared equals c squared. So 3 squared plus 1.73 squared, take square root of it, 3.5. So those are my answers. Oh my gosh. 2 meters per second and 3.5 meters per second. That's my final answer. This is nasty. There's got to be a different way. And this is the way I think of it. You know, this is the way that I'm pretty sure most physicists would do this. But I mean, aside from the matrix thing, like, you guys are going to have, if you're not comfortable with matrices, which I don't know how many of you are, you're going to have to use substitution to like whittle your way through this crap, because I have no other, I mean, I could do it. I think it would take me more time, and you might be thinking, oh, it takes just as much time to like enter in your matrix, but it's really just plugging and chugging for me, because I just enter it in, hit go, the calculator tells me the answer, boom, I'm done. So there it is, a little bit of witchcraft. Hardest problem I think you've maybe seen all year, only because there's 3 unknowns. But if that doesn't faze you, you're good to go.